Yes, as said, Mats-Olov Eriksson. I work with King since 4 years. I started in 2009. For those of you who do not know about King, we are a gaming company located in, well, several countries. I think I included a map, but we started in Stockholm 2003 by 4 guys that came from Spray and a 5th guy that came from Spray, Germany. And he opened up a London office. And, well, it was the end of the .com era that produced King. So we have been in the visit count business before starting a gaming company. This was Thomas Hartvig. I talked to him a month ago, and he's quite amazed of what he has accomplished. He's a normal guy from Virserum, that all of a sudden is the CTO of a 600 people company that is leading the charts in almost all countries. So we started here ages ago. We were doing skill games. We had a platform where you challenged a friend or an unknown person, betting €1 or less than €1, and the winner would take 75% of the prize pot. So we, in effect, took a rake from that. So we did skill gaming, not gambling, so we could do this in several countries. And then came Facebook. And to be honest, we were not the first game developer on Facebook. To be even more honest, we have never been first with anything. I think that Microsoft had a motto saying, embrace and extend. That's what we do. Zynga, they beat us to Facebook. Their game Farmville had about 100 million users when we launched our first social or Facebook game. We call it social internally. But we looked at what they were doing. They had a virality feature that was awesome. They incentivized you to invite your friends to the game and thus having free marketing more or less. And we tried to do the same. We had a few games out, and it was not until a game called Bubble Witch Saga when we started having a daily active user count of millions, and I think that game peaked at 7 or 8 million daily active users. And then came mobile. Same thing there. We tried out a few games to see different concepts, trying to learn about mobile game development. We are very self-taught in many areas. I'll show you some downsides of refusing to listen to other people later on, but we think that a part of our success is that we actually try out different things instead of taking too much advice. But the first real hit on mobile was Candy Crush. And Candy Crush now is close to 100 million daily active users, and it has just we were not expecting the success of Candy Crush. And I think budget-wise, we beat the budget for 2013 in February, and we're pretty good at forecasting. This is sort of how we do games. We start with our own platform, which is still King. So the skilled platform is very valuable just to try out different IPs. When something seems to work among the hardcore audience we have on our own site, we take that to Facebook, because it's always safer to have a game developed in its social envelope on a platform where you can do multiple iterations fast. For those of you who have tried producing an app on the Apple Store, knows that there's usually a 10-day review period, so updating a client if it doesn't work out the way you thought it would takes at least 2 weeks. That's bad for improvement. So we fine-tune it on Facebook. We can get better data on Facebook too, and then when it seems to work, we launch it on mobile. I think this is an old slide because we have more than 3 games. And my purpose with this talk is to I'm not conveying a message. I'm not really trying to teach you anything, but it's more of a premature post-mortem of what we've done and how we've managed to scale the platform and the decisions that we made during the way that allowed us to have about 130, 140 million daily active users that we have without having too many machines. We're still not over 200 active game servers. We don't have more than 40 machines running the data warehouse. So this is what we used to do. I have lots of animations in my PowerPoint, so if you don't like animations, well, you came to the wrong presentation. This is the game servers. Usually we have a SQL engine database where you have user data, so when you log in, you would just upload the user object, get your money if you have a money account, your friends and whatnot. And the same database is used for tracking. So if we want an extra piece of information with every game end, we would need to update the production database, and that will be done every fortnight, Thursday morning. It took us at least 30 to 60 minutes of downtime to update a game, just because an altered table in our production environment was not only scary, it took time. That's how a SQL table looks. And we just had a batch and copied everything into our data warehouse. It wasn't really a data warehouse either. It was a ClickView machine that I set up to rid the developers from all the queries that they got from the business. So how many players did we have yesterday? How many games did they play? How much money did we make? Yeah, there was a time when we actually had to ask developers for the revenue. And the downside of this is that you have 3 dependencies on your metadata. This is a word that you will hear a lot tonight, the metadata. I'm a big fan. Because the game servers need to know what to track and how to track it. The storage needs, of course, the metadata, and also the data warehouse to interpret whatever data we have. So what we did in 2010, the guy called Lars and myself, had a bottle of sherry and started thinking about how to scale the next generation of platforms for our social games. And we didn't really know that we would have mobile games back then, but we try to have it as generic as possible. New animation, game servers. So we limited the user data that you need to be able to play the game as much as we could. And we also changed the way we stored it. So we now have a key value storage with the value being a JSON object. So we have a very dynamic user data storage. And we use InnoDB. I mean, that's just I don't know why. Patrik Stimmen is a big InnoDB fan, and he's one of the founders. So you have the last say. This makes us very agile, because if we want to add something, we only add an object and update the metadata within the game, so we can easily add more information to the user object. And instead of having a database to write all the pieces of information that we wanted to track, to be able to optimize games, to be able to know more about our players, we started just writing everything into log files and then transferring those log files into HDFS. So we set up a small Hadoop cluster. We started with 8 machines, and that gave us only 2 dependencies for the tracking metadata. So we, by this, separated the analytics platform from the game platform, also minimizing the risk of the games being affected with something that an analyst would do. I've met a lot of analysts, and not everybody are SQL experts. So we don't want them in anything close to production. And by this, we could have this going down without any game being affected. So what happens is that we just take it into HDFS, and then we added a more, for those of you who have worked with Hadoop or tried Hive as the interface to your data, knows that it's everything but responsive. It's more of a diesel engine. It will deliver a result sometime, but not as quickly as you might want to have a daily ETL to produce some metrics for the business. So we added an MPP, which stands for Massively Parallel Processing database on top of this. We take a subset of the data, produce the ETL, push that into a ClickView machine. We use ClickView as the presentation tool, and then we show the profit. So what is the metadata-driven data warehouse? And what's the upside of having a metadata-driven data warehouse? I love to say that sentence. Well, if you recall this image, yes, I love metadata. We have a game developer who gets an idea of something that should be tracked within the game because we want to know more about the game end. When you have finished the game, we want not only to know what score you have, we want to know how many stars you earned. Because believe it or not, at a design time of how we should track things, we have never been able to think of all the different types of analysis that we would like to do. So it's important to have a very dynamic environment for us to update the tracking without having alter tables or downtime. So that developer implements something in the metadata, and this is how our metadata looks. This is the event type class, and you will see that he added a Juego game end. Juego is our game framework, and he adds an annotation when the level has ended. This is what the code would look like. Sorry for that. My indentation was horrible, so I had to insert some sort of joke to show you that I do know how to indent Java. And it's implemented. Then that developer goes into the game, in this case Bubble Witch Saga, and adds that tracking to the game round API. And as you can see, we added this log app event. We just say what event type, and he adds the parameters that we want to have to be able to know more about the game end. And then the game goes live, start producing this event in the log files. The metadata is used to parse these log files, because as you can see, the return is strictly typed, so this is the exact order. So we can use the same method to parse and interpret that log file. Yes. So this is parsed into Hadoop. I always vary the way that I depict Hadoop as a system. It's talked about and it's almost synonymous with big data today. But the most important part of it, depending on what kind of analyst you are, it would be Hive if you don't prefer to write Java, because you can access it using Java, Pig, Hive, and a bunch of interfaces. But for us, Hive is the key component because it offers us a query language that is very SQL-like. And then the metadata is used to sort of construct the data warehouse structure within Hive. So this is whoa. Plus. And this is just how we go from the event type declaration through XML, and then we have an HQL statement actually creating the table. And then we have our data scientist wanting to know more about what can we possibly know about a game end. He looks in the metadata, and he sees that we have a game end event from Juego, brand new, with the number of stars. And he goes into Hive, queries Hive, and reports back to the business. This is the interface that the analysts have. So we've created an HTML view of all the events with a description so that you can just browse through. This worked fine up to 400 events. I think we need to refactor this method of displaying our information, but we're not there yet. This is to show you some of our dirty laundry. Imagine this, but 500-600 different events. A new data scientist comes into King, fresh out of the uni, and gets hit in the face with reality. I've seen that happen many times, and I like this. I usually present a lot to BI people, and they just love their governance, data governance. It's a very hot topic, and what I try to do is to explain that governance doesn't have to be boring. If you have a well-structured metadata-driven system, you get governance by good design. because then everybody shares the same definitions. There's no way that you can track an event, add some parameters of your own. Preferably you add the whole tracking into shared code, so we have libraries that all the games share, so we can have a module for tracking game end the same way in all of our games. And as you can see, we iterate a lot, and this is one of the upsides with the whole metadata-driven system, because we always add new parameters to the tracking, and this we can do without alter table at all. This is the different credits transaction. This is the Facebook purchase when they still had credits. Oh, they might have credits, but they're, I think, next week, actually, they're doing a major change into a new payment engine. So there will be no more credits, but there used to be. And this happened, this is a year worth of iterations. So then, in all this big data, NoSQL, real-time world, what happened to data warehousing? Well, not that much, to be honest. I'm conservative, despite being like 23. And it turns out that Ralph Kimball had already invented everything we needed. How many know of Ralph Kimball? Okay. He's more or less the godfather of data warehousing. He worked at Xerox in the 70s, where they invented everything that is worth inventing. He had this dimensional model that he suggested to be a good structure in data warehouse. As you can see, we have all these events. This is just a snapshot of a few of them. And it doesn't make sense to start reporting or try to write your report script from 400 different events. So somebody needs to maintain that, and you need to have a team that does what is known as ETL, extract, transform, load. And then you have the dimensional model. This you have probably seen. You have a star schema with your facts, and then you have some attributes to the fact, which could be a user dimension, it could be device dimension, and we could add something else that would sort of describe the agent that produces the fact. And it's a very neat model, and it has been around forever, and it will never go out of style, no matter how many NoSQL techniques that hit us. And this is how it looks. So we have a clear naming convention, so you know that if you want social purchases, you have a fact table with social purchases. And then another word that is very popular is real time. When I wrote the headline, I got buzzword allergy, so I added a few more buzzwords. This is according to Wikipedia, all the buzzwords in technology today. I think there are a few more. We are not even close to being real time with what we do. A CEO might claim that we do real time, and we do it in some cases, but real time is more a philosophical discussion than it is practically feasible, because that last second of latency reduction will cost you a fortune, and nobody really has a good idea what to do with it. So we have what our British head of data warehouse calls toast time, and that's the amount of minutes it takes for you to go out and make a toast, and then come back and have your data. What we have done, experimenting with a technique called Kafka, developed by LinkedIn. Funny anecdote about that is nobody in the management team thought it was a good idea experimenting with this, because we had to have a few guys that worked on Kafka with Zookeeper and everything that maintained it, until we said that LinkedIn invented it. And all of a sudden, they were all for us experimenting with Kafka, because they want to sit in their sea-level sauna and talk about the latest LinkedIn technique that they use. So we added a Kafka producer on each game server. So we not only write the log files and transfer them through a batch process, we also have a Kafka producer which changed the topic structure. So what Kafka does is it produces data on a topic, and then you can have a consumer consuming that topic or all the topics, depending on what you want to do with the data and depending on the topic structure that you have selected. So we have this on all, and then we added a consumer on the HDFS to see if we can get it into Hive in a more rapid fashion. But Hive by design has a latency, so we'll always lag about 15 minutes with the schema update. So this is a listener, and then we can add more applications, and I'll show you such an application. The things that we could do once we have got this more stable. Kafka isn't plug and play. It's an Apache project that is being worked on, but it's far from ready. And what we would like to do is a word that came up in the previous presentation, personalization. Because if we can have more data fed into the games in toast time, we would be able to design certain features of the game based on what we know of you as a player. So if you're a very skilled switcher player, we might present you with more difficult levels first time you even play a new game, because we don't want you to get tired or think it's a child's game. And if you know that you're a poorer player or a switcher challenged player, then we could present you with a very basic tutorial so that you get hooked on the game slowly. But we're not there yet. But that would be something cool, or something even cooler. But one application that is live and that has enabled us to do the mobile marketing that we do is a real-time system for mobile ad attribution. The problem with mobile ads, and especially on iOS, is that if you see an ad in your mobile device and you click that ad, you go to the App Store and you start playing the game. And there's no way that Apple can pass a parameter saying that you started playing because of this ad. And I don't know why, because, I mean, a referrer ID, Google has it, but Apple simply refuses. And even though we're a big company, it's sometimes like talking to a wall. They're way too wealthy, and they have become a bit arrogant. I'm not slandering Apple. I love Apple. I have like 2 Macs, 2 iPhones, and 1 iPad. And I'm also a hipster, I know. But I think that they're making too much money out of hardware. So talking with software developers is not really their key priority. So what we've done is, you start playing this. Very straightforward. I thought that this would be animated. I'm a bit disappointed with myself. So what happens is that you click an ad, you're redirected to a server that takes a fingerprint of your device, a fingerprint based on lots of parameters that goes into it, and also your time settings on your local device. That has a Kafka producer, but let's talk about that later. You go to the iTunes store and you start playing the game, and then you're sent back to the same fingerprint thing, and if the fingerprints match, then we know that you came from this ad, so then we can spend more money on this channel. This is the basics of performance marketing. You look at your return on investment, and if it's positive, then you just keep spending on that channel. And, well, we do some paid marketing. I can guarantee you of that. But what we needed was to have this in real time, because we need to optimize our channels continuously. So we had a Kafka producer saying that this channel seems to work out well, and that it's distributed back to the ad networks so that they can say, wow, let's increase the spend. So that's more or less the only live and business critical system that we run on Kafka today. We will have more soon. And then analytics. What do we do? I am not a good analyst, and I had to talk to the data scientists to really get some good images to have in my slides. But I know a few things. I like reporting. I'm still deeply involved with reporting. Just this is what we report on. We have, of course, the usual dashboards with your gorges and whatnot, whatever the management wants to look at when they eat breakfast, and look at the KPIs, feel they high-five themselves. Just some things that we look at, game performance. I think last but not least, game performance. The Zynga kind of created this illusion that the social gaming companies would use data only to track you as a user to make more money and squeeze the last cent out of you. But you can do a lot to just improve the game performance. How you interact with the game is important to keep you with King as a game developer, because we try to have a brand and we take care of everything that could be used as indicators of you getting sick of King or reacting to spam if you don't like to be sent too many messages. So game performance is not shouldn't be last on this list, but it's in random order. And then science. What is that, and what's the difference between science and reporting? Well, then we can debate about that forever, but it's more sophisticated and they use methods that I don't know that much about. So machine learning, you can have more cross-game behavior and the probability of you liking this game based on your behavior in that game. So then we know if it's worth it to cross-promote you between the games, because cross-promotion is the tool we have to move users between our games if they show signs of not playing as much as we want them to do in the game that they're currently playing. So then we can have a sophisticated way of cross-promoting games. And segmentation, of course, because the more we can label you, it's okay to label people in analytics, not in life though. The more we can label you and know, or with the likelihood that you would like something, the better we can produce games for a certain segment. And virality, of course, as mentioned. Virality is why we always have a social graph attached to our games. And, well, as a tangent to Pontus' presentation, we have just launched, instead of having a Facebook Connect feature, we have now Kakao Connect. Because in Korea, Kakao was fairly popular. We saw that we can't just force people into Facebook. We need to be where the users are and the way that they want to send messages to their friends. So it was only a week ago when we launched that, and it'll be interesting to see how that compares to Facebook as a social graph on top of your game. And debug, of course. Yes, we have bugs, and we need to debug them. So a few use cases, what we did and what we changed. If anyone has anyone played Candy Crush? Ah, good. I'd be disappointed if no one had. Statistically, at least 2 of you should have. So the level of difficulty, it needs to increase because you need to be challenged. But it can't increase too fast because that will be a blocker and you quit playing. So these are the prerequisites, and this is a level 65. It was a tough one. And the story of level 65 is that the producer of Candy Crush, Tobias, tried the level and accidentally finished it with 3 stars on his first attempt, saying that this is way too simple. You need to make it harder. So they did. It turned out that it was a fluke that he finished it so fast, and we didn't do proper testing before releasing this level, so he was the only one testing it. And then we saw after 1 or 2 weeks that the average number of attempts that you needed to complete level 65 was more than 150. That's bad user experience. But people kept playing. It was insane. And 150, that was the average. So, yeah, you had some outliers to reach that average. So this is what you saw most of the cases when you attempted to finish it. And the way we discovered this is that before we created an app just to monitor. This is the code that we wrote. You wanted some code, Mikael? This is code. Or script. I know, it's the business version of coding. And we added this into ClickView, and we presented it like this. We usually don't have this many cohorts in the same, but this is what I call obfuscation by adding way too many dimensions. because I'm not allowed to show you real data. Instead, I just add dimensions until it's incomprehensible. So we just see what's on what level are they stuck. So what was the last level that all of our active users played, or not the last, or the highest level they have reached. And then we could see that 65 spiked, and then we could do something about it. So next release, we removed some chocolate. Yes, we did remove some chocolate, because chocolate is an obstacle, and it's always fun when you think about the terminology that we use, like add more licorice, because it's way too easy. And another case that I think is interesting, just to show you some of the ways that we can present data. Visualization is also something that I enjoy thinking about and experimenting with. So in this case, we wanted to make sure that the experience you have on mobile is the same that the one you have on canvas. When I say canvas, I mean web. That could be Facebook. Yes, we have games on Google+. Not as successful as Facebook, but we do have them. And we have our own site, so web is sort of where you play on the web and not a mobile device. But it's different to play a game on a mobile device than on web, and due to the fact that we couldn't use Flash, for instance, most of our mobile games are rewritten. So the mechanics may vary a bit. And we need to not only do quality testing of this, we need to have quantitative testing of what's the difference in terms of user experience on mobile and canvas. Text. And I think it was 184, when we, and you could call this a bug, but the chocolate behavior turned out to be slightly different on mobile when implemented. So this level became more or less impossible to complete. And this was quickly discovered thanks to some code, some more code, and this way of displaying the number of attempts on the two platforms, so you can easily spot deviations from that expected line that tells you that you do as many attempts on canvas as you do on mobile. And here you have a few outliers, and it's worth looking into. It's not necessarily a problem, but it could be a problem, and it should be subjected to rigor testing. And I like this way of presenting it. It was a guy called Matthias who'd been in medical, and apparently this is something commonly used in pharmaceutical. So we tried it, and it grew popular. As the last just part of my presentation and the analytics section, the quantification of the fun. So this is normal progression in our games, and just a few ways that we look at it on a daily basis to make sure that the smooth ascending curve can be seen. This is per level on the x-axis. We can see total number of attempts. Total number of failed attempts varies a lot. And we can see probability of passing a level, and we use pass-fail rate. And these all goes into the producers and the game designers' everyday routine to make sure that what they have put out there seems to be working according to our design. And also average stars earned. 1 star means that you have completed the level, and the no stars is a failed attempt. And average play time. And because most of our games are not time-based. And I think that was the key part of the Candy Crush successes, when we got rid of the time factor. A lot of, only the hardcore players like the stress factor of having 2 minutes to complete a puzzle. But if you don't have time, you can make more complicated puzzles, and people can play for a minute, then hop on the bus, play while they're on the bus, and then they can play while at work. We have done a few very interesting pieces of analysis on when users play, and it's very obvious that not everybody works 8 to 5, but that's more or less it. Thanks for showing up.